Hello everyone. My name is Géza Kulcsár from Inquiry Labs, which is a Budapest-based Hungarian company aiming at providing innovative solutions and research to the systems engineering community, primarily also looking at other industrial domains. And it is my pleasure to be here on this conference with Manning, a Graph Data Science edition of the Live at Manning series. And I wouldn't even waste more time. I would just directly jump into the matter because I think you already, after reading the title, are pretty curious if language models in the end understand system models. Of course, we will have to start with a clarification of the concepts and notions appearing in this title and this question, which we are after here. So, the first overall question is, how do we, maybe essentially as humans, understand systems at all? How do we interact with them? So the simple answer is that if we want to approach a system that is in maybe a first approximation, a compound thing serving a certain purpose, is that this interaction happens via models. Now, of course, as it has been done in the history of science since ages, this model can be a linguistic one, of course. So here I just included a random word cloud on engineering. So of course, using this conceptual field, people, practitioners have always been able to give or convey an understanding of systems to their peers. Whereas there are other approaches to this as well, which I just simply call formal for the time being, meaning that one uses something of a systems modeling language or a systems modeling approach to have a formal model of the system representing its constituents in a formalized manner. That's right, but we still have to explore a little bit more. What do we mean when we say we are modeling something? Okay, again, now this can have, building upon this same parallelism, which I have just set up on the previous slide. What a model does mean heavily depends on its context where it's used. So having these two sides of the coin, as in the previous slide, one might say that if by model we mean a language model in the sense that this is used in natural language processing, then what we have is pretty much a numeric representation of a text, of a textual corpus, or maybe even the meaning of a textual corpus, although this notion of a meaning is sometimes disputed. On the other hand, if we are looking at the graph model, and a system model is typically a graph model, by the way, meaning, here the word graph implying that it is the mathematical structure, or it resembles the mathematical structure known as graph. That is, it is essentially a network. And my argument is that a graph model is an entity or a structure where the meaning is encoded in its relations. But there's a bit much more to it. We'll see it in a minute. So the field of techniques which we are about to, to employ and explore here is that of natural language understanding. So without going into details of state-of-the-art of natural language processing in this talk, let us just have a simple take on this here, a simplistic take. As you might be aware of, there's an ongoing revolution in natural language processing techniques, especially when we look at one of its main branches, which has become known as NLU, Natural Language Understanding. The results, which are now just flowing in one after the other. The newer and newer results provide better and better solutions for automatically interpreting general text. Here, of course, we should focus a little bit on what do we mean by interpretation. These can be several different tasks. In this talk, we are focusing on the specific task of wanting to retrieve some dedicated, directed piece of information from a bigger context. Now, NLU techniques actually rely on, at least for their machine learning aspect, they have been trained on general documents, that is mixed purpose documents coming from a layman context, let's say. So this means that if the specific input which you want to use NLU for resembles that or corresponds with that typical context where NLU comes from, then you can easily get quality results for your own examples as well. However, as it might sometimes be the case for systems modeling, sometimes there's a specific meaning to the text, which is maybe originally even meant to be understood by the experts only. But then at some stage of the process, you might still want to make that meaning, make those notions more approachable, more accessible, more available. This is what we're after. Another related issue is that some people even claim that even if you take the most successful entry in that catalog of NLU algorithms, which is BERT, I'm pretty sure you have at least heard of it. Some people even claim, and I think rightly claim, that even if we talk about understanding what language models such as BERT does, is not really understanding a meaning, but it's rather just learning the form of the text to an extent that it becomes meaningful as an external representation. So what we are about to offer is of course not a general solution, but a specific take on that, how that semantic bridge can be probably established by combining insights from the system modeling and systems engineering perspective and from the natural language processing perspective. So let me just give you this very simple but correct interpretation of what a system model now is, building upon what I've said. It is a graph with a well-defined meaning. I could have even said formal, but I wanted to avoid this, from a previously fixed technical domain. So there is an additional interpretation to this graph, which is not obvious, which comes from the understanding of a certain domain. I just wanted to give you some background on where this comes from. So this whole field has been known as MBSE, for Model-Based Systems Engineering, where one of its main groups defined as the formalized application of modeling to support system requirements, etc., etc. So here the emphasis is on it is a formalized application of modeling. And in turn, there's a standardized language typically underlying such activities, which is called SysML, for Systems Modeling Language. It says it's a general purpose graphical modeling language. Here, graphical also means visual and also means graph-like. For specifying, analyzing, designing, and verifying complex systems. In particular, the language provides, and this is where I put a strong emphasis on, graphical representations. Again, I take it with a double meaning, with a semantic foundation. So there is this meaning implied, and this is what we are about to explore now. So from a more of an actor or stakeholder perspective, what is the challenge which we are facing? A typical workflow in systems modeling would look like you're having some systems engineering artifacts. then you have to have some specific knowledge to query them, which is, so this guy over here, this rules all the landscape. He is like kind of a single point of failure. This guy is inevitable. He has the knowledge to formulate queries to retrieve the relevant pieces of information from that artifact pool. And then once you have them, those are, yeah, pretty much inside a certain ecosystem. Therefore, you have to somehow post-process them if you want. And even if you have created some kind of reports from them, even if you have understood them, because you have to have this particular combination of expertise in modeling and in the domain where the system engineering artifacts come from, the burden of analysis comes back to this very guy. This doesn't have to be one person, but this is one persona behind this whole process. So it is it has a very low level of approachability from the outside. Instead, the vision which we are about to advocate here is that you take, of course, you build on the expertise of a system modeler in the modeling side of this divide, but at some point you might want to enter into the textual domain by, instead of just post-processing and analyzing it within the usual space of MBSE, you're turning your models into textual documents. And then by using NLP or NLU in particular, you are creating a language model representation over which, as to the, according to the state of the art, you are able to offer analysis capacities to a much larger group of people. So now this is this mixed group of people who might know about the domain, but not necessarily about systems engineering, come into the picture. Technically, we're gonna enter into a short demo pretty soon. We build upon a product called Inquiry Suite, which is offers much more than that. I will not go into details in this talk. This is, generally speaking, a tool to analyze your whole digital thread, which in systems engineering means all those different domains and aspects where your overall engineering data might come together. You combine those, you understand the inner semantics. So this is all about semantics. And on the user side, what Inquiry Suite offers, it offers loads of different front ends where you can interact with it. But a typical example is that you're creating something something web-based like a Jupyter notebook, which I will also show in the live demo today, and you're then processing your data in an understandable, accessible manner. So this is time to go live. Let me just give you a very brief look into how the original established tooling of this field might look like. So this is where you have your model. This is a, a well-established systems modeling tool. I take an example. This is just a showcase example, publicly available. This is an artificial example of some aspects of an SUV. But let me just switch to my notebook here, which I've prepared. So I'm connecting first to the Inquiry Suite. I will go through these phases rather quickly. What's happening here if I'm able to choose the model which I want to query interactively from the cloud. So there are collaborative methods to do so. Sorry, we'll have to do it again because I shouldn't have rerun this part. Sorry about that. Let's go ahead. Yeah, some indexing is happening. It gets loaded in the database. Now, if you think of this vision, now we are at the querying part. We are still in the modeling domain, and we are querying the things right now. And after that, we are registering our queries. Okay, we just registered our queries. And based on the queries, now we are generating text. So now we have come to this particular point of model to text generation. I'm going to slow down here a little bit. So what essentially happens is that there are certain aspects of a system model which we want to know of. These are just typical entities of interest for a system model, such as the packages, the overall organization of the data, blocks, so the basic system constituents, values of some properties. So this all gets queried by MBSE means with built-in capabilities of the inquiry suite, but this all gets turned into a dictionary in order to create this bridge to the NLU technology, in this case BERT, which we want to build upon. And okay, so as you see here, there's a querying output, but this is still not processed. So this is what I thought. This is an internal representation of the result of querying, retrieving data. There's still no particular processing happening. And in order to get that kind of vision which we want to arrive at, now we are turning it into text. So what you're seeing now is a bunch of text representing the hybrid SUV example as a textual corpus. So for example, the model package, this is the container, but contains the transmission block. There is a transmission in the car. The transmission block contains a full block type, full supply product property. This is still systems modeling lingo, which you see here, but it has already turned into a text, and the actually interesting part comes as we start to see what happens if we want to perform semantic search on it with BERT. So I will go on. I'm just configuring my BERT framework here. This is just technical stuff. I'm building a BERT model. Sometimes it takes a bit longer. I hope it won't take too long. Yes, we are there. So as you have even with my simple laptop, it was not terrible in terms of performance. And now I'm looking at some sample queries. Let's say I want to take a look at if we have something related to environmental awareness. First of all, good news is there is a bunch of relevant so of course there will be much more than that, because this is based on some kind of internal similarity, but these are the top results, and I think this is pretty satisfying, looking at, for example, some properties of the environment block which can be related to the actual issues of environmental awareness, which was my my search term basically. And also there are other things. Of course, this still should be verified if this is really as strong as it looks. But there's a fuel efficiency equation appearing here. And by this trace, for example, if I want to take a closer look at this guy, I get its ID from the modeling side, meaning that I can come back here and navigate for the environment, finding this block based on its identifier. And then there are also other queries, like for example, what properties do we store about fuel? And then, in fact, sometimes the word fuel appears, sometimes not, but then we get things which feel like being connected, relevantly connected to fuel storage, etc., etc. I could go on about this, but I think by now I have, or you have got the gist of it. So I will just return here for a quick takeaway to the answer. So what we have seen is the system models have an inherent semantics coming from the graph structure and the encoded domain knowledge. However, they might be pretty hard to explore and comprehend due to their size and appearance. Therefore, we propose their textualization to combine the strengths of the MBSE and the NLU field of applications. That is, we want to reach a natural language model understanding here, and the first results which you have just seen are pretty promising. However, we are still at the beginning of a pretty long journey, while we have employed the state-of-the-art technology, which is BERT for context-sensitive language modeling, we still have to find a way to fine-tune it to perform even better in our role domain. And also, we might want to have a systematic evaluation to see if and how other BERT-like models really improve the contextual understanding of our system models. So with that, I end my talk. Thank you very much for listening. And if you want to reach out or have questions, I'm more than happy to answer. You can reach me on those channels which are listed on this slide.